Okay, welcome everyone again who has just joined in. We are starting exactly right now. Welcome, my name is Gabriel, and welcome for the last webinar of the year. Hoffman is now hosting this webinar about the role and function of plate heat exchangers in the food and beverage industry. So welcome. I really hope you're gonna have an amazing time today. Thank you for your time. Thank you for being here. And I really hope you're gonna have learn a lot and understand better about the way the heat exchangers work for this industry that is so important for human life, and not only this industry, about the devices themselves. Without further ado, let's start the presentation so that we can start this webinar. Okay, but first of all, let's make a very quick introduction about what this webinar is going to be about. And for sure, I'm going to introduce myself. Some of you already don't know me yet. So for those who don't know me, it's nice to meet you. My name is Gabriel. I work here at Hoffman. I'm a master's student of international business at Beijing Foreign Studies University, and as well as Buenos Aires University, University of Buenos Aires. I know I don't recommend people to do two masters at the same time, but yeah, I'm here working for Hoffman for a while. And you can see I've already presented some webinars. This is me in a previous webinar with a shorter hair, but anyway, well, I really hope you're gonna like the way I explain the things. I really hope that I can pass the knowledge we have here at Hoffman, the expertise to you, so that I can learn valuable things about this webinar today. So this is our agenda. We're going to start with this is the introduction we're doing right now. Very soon we're going to have talk a little bit about the plate heat exchangers themselves. I know some of you are already familiarized with the plate heat exchangers, but I also know that we have people with very different levels of familiarity with these devices. So it's important for me to at least give a little introduction about some kind of plate heat exchangers that I'm going to be explaining here, so that everyone stay at the same baseline and everyone can follow up the explanation. So I'm gonna make this quick introduction about the plate heat exchangers themselves, so that only after that I can talk about how it's going to be for the food and beverage industry. So then I'm gonna talk about the common application of these plate heat exchangers, how they're used for many different products. You see like edible oil, milk, juice, many different products. They use heat exchangers in different ways. And I'm gonna give you a wide perspective of them, but I'm going to be focusing very soon on two of them. I'm going to be talking about the raw milk pasteurization in order to better explain the pasteurization itself. It's going to be a very illustrative explanation with a lot of images so that it can be easier for you to understand. And I'm also going to be talking about beer brewing process. And why did I choose these two? Because these two, through them, we can understand the general idea about how the process work for plate heat exchangers. For sure, we have many different products with many different features and many different requirements. So some details are not going to be the same in for example, the pasteurization of milk and pasteurization of juice, for example, are not going to be the same way exactly. But from the explanation, we're going to have a wide perspective, so that we can start understanding how it works. And then, after explaining how it works ideally, we also need to talk about real life, about the real life problems we have, the real life issues, and how we can avoid these issues to happen. And finally, we're going to be talking about Hoffman, all our expertise, and how we can help you find the best solutions you're looking for or your client is looking for in the food and beverage industry and the heat management. So without further ado, let's talk about the plate heat exchangers themselves. Okay, here we are, plate heat exchangers. Let's talk, what is a heat exchanger in the first place? It's a device that is used to promote heat transfer between two or more fluids, allowing cooling, heating, and temperature regulation of this fluid. And because of this, in many industries, we require some optimal temperature to have the physical and chemical reactions we are interested into. This is the reason why plate heat exchangers are important, because with them we can deal with the heat management, with the temperature management in an easy way, and we can optimize the reactions we're interested in many industries. And For food, it is quite important as well, because in order to have the final product with the desired features, we also need to monitor the temperature during the process. And here we're going to be explaining how the heat exchangers can be used so that we can monitor this temperature and the thermal energy exchange, such as this process, such as heating, cooling, pasteurization, and disinfection. All of them require temperature management somehow. Okay, let's talk about the kinds of heat exchangers. I'm just going to be talking about a few kinds. There's a universe of kinds of heat exchangers. But the first one I want to talk about is the gasket plate heat exchanger. It is basically formed by a series of corrugated thin metal sheets and gaskets, and it allows the fluids to be separated. They do not mix it between themselves, the hot and the cool fluid, but they're going to exchange thermal energy. In other words, heat. And here you can see the pictures. And here in my hand, you have a miniature of the heat exchanger. Oh, for sure. Some of these devices, they are even bigger than myself. Here's just a miniature so that you can understand how it works. You can follow up with the drawing as well. One of the fluids enter here and go out from this other door, and the other fluids in the opposite direction enters here and go outside of the other door. And here we can see the series of the corrugated plates with the gaskets. And you see that these plates are exactly this part. These are the plates that are inside between these frames of the heat exchanger. And this is how they are attached together. The gaskets are attached to the plates in order to avoid the fluid to get out of the plate itself, because it needs to be sealed. And that's the function of the gaskets when they are added to the system. Here, from this port, for example, the fluid is going to enter the plate, okay? It's going to flow all over the surface of the plates, and then it's going to go out from this door. The other fluid, on the other hand, is going to be coming from here and going out from here, but these gaskets, as you can see, they do not allow the fluid that is here to enter this part of the plate. They just should not mix, and that's one of the functions of the gaskets. But if you go to this following plate, you see exactly the opposite. The fluid that is flowing from here, now it cannot flow in this plate. Instead, the other fluid is going to go actually in the opposite direction so that we can optimize the heat exchange. It's going to flow in this plate. And then again, it's alternate. And between these plates, they're going to exchange thermal energy. That's basically how it works. That is basically the principle of a plate heat exchanger, in this case, a gasket plate heat exchanger, because, as I said, it's composed of gaskets as well as the plates. And this is the idea about how we're going to use the temperature management. Maybe it's a little abstract now, but don't worry. Very soon we'll be presenting the images and the examples so that you can better understand the entire process. But now I would like to talk about another kind of heat exchanger. This is the brazed plate heat exchanger. It's also composed of a series of thin plates, but instead of having gaskets between these plates, sealing the fluids and separating them, the plates are actually brazed together with a copper or nickel alloy. And yeah, they're very efficient, they're very compact. Here I have a brazed plate heat exchanger. It's not a miniature now, as you can see how compact they are in comparison to the other that is bigger than me sometimes. So one of the fluids is going to enter here. We have the same system of plates, the same principle. It's going to enter here. One of them is going to go out from this. Meanwhile, the other one is going to enter here and go out from this. So the same process is going to happen between the plates. The fluids are not going to mix. They're going to go in a counterflow, and they're going to exchange the thermal energy. In other words, they're going to exchange heat. Now I would like to talk about another example. It's actually a kind of gasket plate exchanger, but it's very specific and very widely used in the food and beverage industry. The multi-stage plate heat exchanger. We can even see the drawings of the design for the project of them. They're basically a heat exchanger, but they have different stages. As you can see here, sorry. This gasket plate heat exchanger, they have these frames in the front and in the back. But in this case, we have another series of plates after this, I don't know whether it's easy. Yeah. After this frame, and another frame. So it's a two section, but it also can be 3 section. It can be four section. Depends on the use it's gonna have in the industry. So they are very high efficient. They are very compact in comparison to other heat exchangers, such as the Shelling tube heat exchanger. But we're not going to be talking about them today, okay? So it's just for you to have an idea about how they work. They are very easy to maintain, even to convenient to assemble and disassemble as well, because you see, it's just like making a puzzle. We can assemble the plates together, and we can even customize the area, increase or decrease the heat exchange area in order to achieve the right temperature you're looking for. So they're very handy in this perspective, and also very easy, have very easy maintenance and very easy installation. So, and this specific kind of multi-stage is very used in food and beverage as well as pharmaceutical industry. And you can even see that they also actually have stainless steel. I'm going to be talking about the materials for this heat exchanger very soon. But now, okay, I really hope now you understand what they are used for. Maybe the difference between the kinds are still a bit abstract, but very soon we're going to have some practical examples with the milk and the beer. But now I want to introduce to you a little bit of the uses these devices have for the food and beverage industry, and that's why you are here today. So common applications of the plate heat exchangers. Excuse me. Okay. Pasteurization is a process that is very important for the food and beverage industry, because this way we can kill the potential pathogens in the product, ensuring that it's going to be healthy, ensuring that it's not going to generate any health problem to any of our consumers. And it also allows the product to be, it enlarges actually the shelf life of the product. So it's easy to transport for further regions, for them to stay in the shelf for more time, for people to buy. They're going to be still valid. It's going to still be fresh. And this is the reason why it's so important for the food and beverage industry. And pasteurization has everything to do with temperature change, with temperature management. And that's the reason why plate heat exchangers are so widely used in the pasteurization. So the pasteurization is by far the most common use we have for the food and beverage industry. For example, for dairy products, I'm going to be talking about milk, but it's also be used by yogurt, cream, butter. Beverages such as fruit juices, soy milk, coconut milk, all the plant-based milk, coconut water, canned drinks, egg liquid as well, because we want to remove potential salmonella, making it healthy and safe for consumption. And condiments, ketchup, salad dressing, honey, all these products, they require pasteurization to fit the requirements, the sanitary requirements. So yeah, in all of them, they use plate heat exchangers. And I will be showing very soon to you how they work in practice. But now let's talk about other uses they have for, in particular for each industry. Because each industry is unique, each product is unique, each product has a different process to manufacture. And that's the reason why they have different steps and different uses of heat exchangers as well. So for dairy, you're gonna be see very soon. We need to cool the milk, for example. We need to preheat. Is one of the uses of the heat exchangers. I will be talking about them today. You're gonna see how it works. Edible oil is also important for preheating, winterization, steam generation, beer as well, fermentation, saccharification. We're gonna be seeing these things as well. Sugar milling, heating, evaporation, syrup cooling, syrup crystallization, syrup drying. All these processes require temperature management, and heat exchangers are there. Wine fermentation, stabilization, quality control, juice temperature control, sterilization, etc., etc. This is just a very introduction. As I said, every process, even though they're used in many different industries, they are unique. They have their unique requirements, but here we can have a broad perspective and understand the principles. And that's why we're here today. So let's talk now about the practical part with the raw milk pasteurization. So first of all, we have the raw milk, which is extracted from the cow. Actually, it can also be from the sheep, from the goat, from the camel, the horse. Well, it depends. There are many kinds of mammals. depending on the part of the world where you come from. But basically, they come from a female mammal. So the raw milk basically has the temperature of the animal as it goes out, as it comes out of the body. But before, we need to store, in order to make sure it's not gonna be in bad quality, we need to ensure a lower temperature to store it before passing through the pasteurization. So change the temperature management, heat exchanger. Here we have a gasket plate heat exchanger, so the raw milk is going to be entering this from this port, is going to spread through all over the plate, come back to the port, and on the other side we're going to have a cooling fluid, which is water. Is gonna in the opposite direction for sure. The water is coming from here and spreading so that they're going to absorb part of the energy from the milk, and we can reduce the temperature of the raw milk to 4 degrees Celsius. I mean, this is an approximation, okay? Some of these temperatures here are not very specific. It's just for you to have an idea about how they are. For sure, as I said, each manufacturer have their own specifications, but it's a general idea. Now it can be stored, ensuring that it's going to be good for more time. It's going to be fresh for more time, but we still need to pasteurize them because potential pathogens must be eliminated from milk. And that's when the multi-stage plate heat exchanger enters. So in this stage, we're going to send the milk to the first stage so that it can be preheated. So the cold milk is going to exchange heat with hot milk. I know. Very soon I will be explaining where this hot milk comes from, and we will understand why we use hot milk to preheat the cold milk. But that's the main idea. We're going to preheat the milk before the pasteurization process to around 50 to 55 degrees Celsius. But the milk has some characteristics. We need to keep the milk homogeneous before we can pasteurize it. And that's the reason why we send it to a homogenizer, so that we can preserve the features of the milk. Now it's homogenized, and we can keep going with the next step, sending the milk to the other stage where this milk is going to receive thermal energy from hot water. So the hot water is going to do the same thing, enter from the plate, exchange heat with the milk. This way we're going to increase the temperature of the milk and reduce the temperature of the hot water. But this hot water can be used again. If we increase the temperature of the hot water, we can send it back to the heat exchanger and save energy. And that's why we use this other heat exchanger, where the hot water is going to receive thermal energy from steam. So we have a steam generator at around 115 degrees Celsius, which is going to reheat the hot water so that it can keep increasing the temperature of the milk. Now, the milk is at a high temperature. We have hot milk around 68 to 72 degrees Celsius, and we're going to be sending it to a holding tube in order to keep the temperature for a while, around 50 seconds, ensuring that all the potential pathogens, potential bacteria, and any kind of microbes that are not desired in the milk are going to be killed. And now we have this hot milk. But before we can package the milk, we need to reduce its temperature again. So we're going to save the energy by sending this hot milk back to the first stage of the heat exchanger. This way, we're going to do two things at the same time. We're going to be able to decrease the temperature of the hot milk. That's what we want. And we're also going to increase the temperature of the cold raw milk. That's also what we want. So we're going to save a lot of energy, it's very efficient way of monitoring the temperature of the milk. After that, it's not going to be enough. We still need to reduce the temperature of the milk after that. So we're going to send it to the last stage of the heat exchanger, where we're going to have a cooling fluid, which is iced water. So the iced water will absorb the heat from the milk. And now we have the milk at an appropriate temperature. It already had its temperature increase, keep the high for a while, decrease again. We have pasteurized milk. And the milk is ready to be bottled and ready to be sent to the consumer. This is the general idea. This is generally how it works. This is generally how we use the heat exchanger to do the pasteurization process in the milk. It can also, the principle we're going to see very soon for the case of the beer is very similar with a few changes, but that's the idea. That's how we use the heat exchanger. For sure, if you want like a very specific requirement for you to say, Gabriel, I want to know how we do that for honey. We can provide you help. We can understand better your requirement and can find the best solution for you, a customized solution for you. But that's the general idea, so that you can understand what, in the case, if it's your client, you can understand what is your client is looking for. Okay. Now let's talk about the other practical example, the beer brewing process. Excuse me. Okay. Let's talk about the beer. Beer is made of barley. It's one of the ingredients of beer. But we cannot simply use barley as it is extracted from the plant. We need to pass through some treatments before the barley can be used to produce the beer. So we're going to soak the barley for around 1 or 2 days with this pre-treatment so that the barley is going to start to germinate. And this process is important. This germinating barley is called malt. And why is this important? Because when the plants start to germinate, they activate some enzymes. And these enzymes are going to be important for the fermentation process. And that's the reason why we do that. We soak the barley, producing the very famous malt, which is going to be used for producing the beer. But that's not enough. After 1 or 2 days after the germination, we also still need to dry the malt, and pulverize it, smash it until we have malt powder. And we're going to mix this powder to water, producing malt starch. And now we have to make the saccharification process, where we're going to transform this starch into sugary wort that can be fermented. And this fermentation is going to produce the beer soon. But there's an optimal temperature for that. So we need to increase the temperature of the water. Oh, sorry, for the malt starch, by using a gasket plate heat exchanger. So the malt powder is going to enter on one side. On the other side, transferring heat to it, we have steam created by a steam generator at 115 degrees Celsius. And now we have malt starch at 70 degrees, which is sent to a mash tank. And in this mash tank is going to happen the process of saccharification, where we're going to have the malt starch transformed into fermentable sugary wort. Okay, but we still have some expenses. We need to we have some particles in this mix, in this product, and we need to separate it. That's why we send it to the lauter tank. And the lauter tank, we're gonna, some turbines will be spinning around and separating the sugary worts from the spent grain that is not going to be used for the beer. Well, this spent grain can be used for feed animals, for example. It can be used for producing biomass, bioenergy. Heat exchangers are also very useful in this industry, but we're not going to be talking about this industry today. The focus today is talking about the production of beer. So yeah, let us know if you are interested in knowing more about this industry as well. Maybe we can present something, solution about this with all these unique requirements, unique process. But now let's focus on the other side that was separated from the spent grain, the wort. This wort is going to be sent to the boiling pot in order to kill any potential bacteria, any potential pathogens, and even wild yeast must be killed as well, so that we can avoid any potential problem with the fermentation. And in this process, we generally add hop to the beer. Well, when it's going to be added, even it's in the beginning, we're probably going to produce a bitter beer. If it's in the end, we are going to focus more on the aroma of the hop. Well, there are many different kinds of beer. the steps are gonna vary a little depending on the kind of beer we are interested into, but this is a general idea. We are gonna add hops. It's whether it's in the beginning, whether it's in the end, is gonna vary on your client wishes. It's gonna vary on the kind of beer. It's not the focus today. It's just for you to have a broad perspective about how things work. Now we have a very hot sugar wort. We're gonna send to a three sedimentation tank in order to filter it before sending to a heat exchanger, because in order to ferment it, we need to reduce its temperature. So we have like 98 degrees approximately, and we need to reduce its temperature. And you already guessed, yes, you guessed right, we're gonna have a heat exchanger. In this case, a gasket plate heat exchanger, where it's gonna exchange heat with water at 2 degrees Celsius approximately. As I said, these numbers can vary depending on the project requirements of the manufacturer in a way. And we have this. The water is going to be eliminated at 80 degrees Celsius, and the wort is going to be at 10 degrees Celsius approximately, and it's sent to the fermenter, where the fermentation process is going to be happening. The yeast is going to be added to the wort, because this yeast is going to transform the sugar. It's going to break the sugar into carbonic gas and alcohol. If we're making bread, we would be focusing on the carbonic acid so that it would increase the size of the bread, but we are producing beer. So here you're interested in the alcohol, the alcoholic part of the alcoholic component, I mean. So we're gonna eliminate the carbonic acid and keep with the alcoholic part. And after that, we're gonna filter the wort. Now the beer, since it's already fermented. But some kinds of beers, they also have like a secondary fermentation, generally when they want a more mature beer. As I said, there are many different kinds of beer. This process is optional. Some people will add hop to the fermenter again. So we have the secondary fermentation. But anyway, whether it's just one or two fermentation process, they have to be filtered. And we're gonna have the beer, but not pasteurized yet. So let's keep the steps and do similarly as we did to the raw milk. This beer is going to be sent again to the mood stage plate heat exchanger. The first one to preheat the beer, you'll probably guess right, with hot beer. Yeah, it's very similar to the process with the milk, so it's a kind of review. But in this case, we do not need a homogenizer. We can send the preheated beer directly to the other stage, because, as I said, each product has different requirements, and we need to adapt to the necessities of the customer. And for beer, it's not necessary at all. We send the beer directly to the other one so that it can absorb heat from the hot water. You guessed right. That is, we use the brazed heat exchanger to increase its temperature again and recycle. That's going to exchange heat with the steam. So the process is basically the same. Holding tube to keep the temperature high and make sure that there's going to be no pathogen to the beer. We have the hot beer that's going to be used to reheat the cold beer in the beginning. And before we can bottle the beer, we're going to use the circulating water to reduce the temperature of the beer to the right temperature we're looking for before we send the final pasteurized beer to the full sterile filling of beer. And finally, we have our final product, pasteurization in bottles. We have the pasteurized beers in the bottle, ready to be delivered to the consumer, and so that it can drink the beer and enjoy the product they made. And that's how the plate heat exchangers can be used for beer brewing process. You saw, the idea is basically, you kind of get familiarized with the idea after a while. The processes are very similar. They have the unique characteristics. Our engineers are here to help you find the right size of the heat exchanger, the right materials, the right conditions for each product. But that's the general idea. And that's how we are going to use the heat exchangers for this process and many similar processes in other products. So, Gabriel, I actually want to pasteurize honey. The process is quite similar. I actually want to preheat, I don't know, juice. the process is quite similar. So this is the ideal wort. But the problem with the ideal wort is that it doesn't exist. Okay, let me explain it better. We are going to face real life common issues. We need to be aware of these issues so that we can prevent them and fix them when they happen. And Hoffman is here to show you how we use the best practice to avoid you to have the problem and to help you if you ever have the problem. The most common problems we are going to present here. Excuse me. Let's talk about the real life common issues. Okay. Many of these pathologies that are connected to each other. So if you have one problem happening in the heat exchanger, it's not gonna be working properly. So we can also generate another pathology to the heat exchanger. So it's a kind of domino effect, and that's the reason why customized projects are important to understand the demands from the client. Preventive maintenance is also very important because the equipment doesn't last forever. We need to make sure they're going to keep working well. Hygiene is very important for the food for obvious reasons. I think I do not need to go over that. And yeah, these are the key things we need to do to ensure the food quality. And one of the most common problems we have is the corrosion. Remember I told you about the fact that the heat exchanger is many times made of stainless steel. And the reason of that is because carbon steel, general carbon steel, when it gets in contact with water, it tends to rust. And as you know, milk, most of the composition of the milk is water. Most of the composition of the beer is water. And this can generate them to rust, causing corrosion. Not only it's gonna get like undesired particles to the food itself, but it also can generate other problems such as leaks and many others we're gonna discuss now. So yeah, this is the reason why we need to pay attention to the materials as well when making the projects. Leaks, as I said, they are caused by corrosion. They can also be caused by inadequate installation of the equipment. Inappropriate pressure, as you can see here, we have the plates between the frames, and these bolts, they apply pressure so that we can seal the plates between the liquids between the plates. If you put too little pressure, it's not going to be able to keep the fluids inside, so it's going to leak. But if you add too much pressure, it can also damage the gaskets, which is also going to generate other problems and even leaks as well. So there are some requirements. They are very specific and they need to be followed when making the installation. Contamination also happens if you have a leakage, for example. It can also affect the integrity of the product. And for sure, the product should not mix together at all. That's the reason why we have the gaskets to seal or the brace plate in order to avoid it to happen. They're only going to exchange energy, heat, not mass at all. And cloggings. As we remember that before sending the beer, not the beer yet, but the product that would become the beer to the fermenter, we made a quick filtering because here we have the plate. Between the plates, this corrugation, when they are attached together, they generate some kinds of tubes. And as the liquid passes through the tubes, it may have some particles. And these particles, if they accumulate here, it's not gonna let the fluid to spread uniformly throughout all over the plate. This way, the heat exchange is not going to be as efficient as it should be. And we're gonna be wasting energy, waste resources. That's the reason why we need to avoid the clogging to happen by filtering and also doing the necessary maintenance in the right period of time. Okay, and this is how Hoffman is ready to help you. We have our own laboratory. We customize our pieces as well. In the picture in the extreme left, you can see a simulation of a heat on a frame of the heat exchanger. Is this piece here? You can see is the same one that is in your screen. And here we have like the temperature simulation. They add what can I say? They add the data about the fluids that's going to be passing through the heat exchanger, and this way they can calculate and foresee which are going to be the temperature and how they're going to be affecting the frame. Of course, they're gonna analyze many other aspects, but yeah, this is an example about how we work how we use our softwares and our engineers' expertise to produce the better solution. On your top left, we have the test for the thickness of the gasket, which is also important. We need to consider the thickness of the gaskets as well in order to ensure they actually fit. We also have on the top right, we have the thrashing test. They're gonna apply traction to the gasket and see how resistant it is, because the gasket should also resist some pressure. In the bottom left, you have the density test. So it's like measuring the mass of the gasket so that it can calculate the density of it. And the last picture, where the guy is using an equipment that looks like a gun, is actually a PMI test, because as I said, the plates can be very different materials, such as nickel, steel, and titanium. Well, in the food industry, generally stainless steel. So it also has a kind of purity. For example, 99% of stainless steel, we need to ensure it fits the requirements, and that's what this test do. It tests the purity of the materials of the plates, ensuring that it's going to be appropriate for the requirement we have for the food industry or many other industries as well, as we're going to see very soon. Okay, now a very quick introduction about HFM. We talk about all this expertise, all about the way the plate heat exchangers work in this industry, but I would like to talk a little bit more about ourselves and how we provide the best solutions to our customers and try to customize and avoid the problem to happen in real life so that they can have a good result. Here are some of our products. You are already familiarized with some of them, such as the gasket plate heat exchanger, the brazed plate heat exchanger as well, but also many others, such as the plating shell heat exchangers, the welded plate heat exchangers. They are actually used more in other industries, but they exist, and we also produce them. We also deal with clients from these industries. We also have the HFM Select, which is a program you can find in our website, where you can input data about your requirements for the project. You say, oh, I want to use this heat exchanger for milk at this temperature, this initial temperature, we want this final temperature. You input the data, and this software is going to generate some options for you of the most ideal heat exchangers, some options. And the engineers can help you choosing the right one by talking to you, by understanding better your problem, and they can choose the ideal one for you. So in this way, you can input some data. You can have an idea about what kind of heat exchanger we may be looking after, and our engineers is going to give you a hand in order to choose the most appropriate one, the perfect solution for you. So this is HFM Select. You can even explore that in our website as well. These are some of our services. So we have the fooling and cleaning. As I said, it's important. Plate heat exchanger design. We can customize them as well, depending on your demand. Our engineers have years of expertise doing that, dealing with the most rigorous requirements. Financial supply chain, local logistics, training courses. We also provide them. If we're looking for something way more specific than the webinar today, you can also be in contact with us. The e-shop. We have the souvenirs as well, like this small USB that has the shape of a gasket plate heat exchanger. We have our pens. You can add your logo, in the case of the pen, the website, it can be added. I mean, there's a minimum amount if you want to personalize them, but you can find them in our store. That's this and many other souvenirs. So, even this miniature of heat exchanger you can also find in our online store. So if you are interested in them, you'll find them cute. You can also look for them. And these are some of our solutions, the industries we work at. I talked to you a little bit about the dairy industry, the beer industry, but I also talked a little bit about how they can be used in wine, edible oil, beverage, pharmaceutical, HVAC, sugar. All these industries, they have temperature management. They have plate heat exchangers being applied to them. But even more industries that are not very related to food and beverage industries, they also make use of heat exchangers, such as oil and gas, LNG, fuel cell, power plant, petrochemical, semiconductor, district heating. All of them They somehow have temperature management. They use plate heat exchangers, and Hoffman is ready to help you if you are looking for a solution in one of these industries. We have all the expertise, all the details we know about food and beverage industries. We also have the engineers who know the details of the applications for each of these industries. So we can find the best solution for you for thermal management. These are some of our certificates to ensure and validate our dedication to quality and to deliver the best solutions and to keep clients satisfied. We have the 3A, sorry, the 3A certification for the food and beverage industry, for example. We have ISO, CE, and many other certificates. We do our best to ensure that we have the best quality. We're actually delivering a quality solution to the clients, and the clients are going to be satisfied in the end. And these are some of the satisfied clients we have already who trust us and like our job. So we can see, for example, Nestle, Coca-Cola, PepsiCo. Tsingtao, for example, is a beer manufacturer very famous here in China. So they trust us and they apply our heat exchangers in their process to deliver high quality products for our clients, for their clients all over the world. And that's it. It was I really appreciate the opportunity of being here. Thank you, Hoffman, for having this another webinar, and thank you for being here, giving us your time to learn, to dedicate yourself to learn more about the heat exchangers, to learn more about the industry of food and beverage, how these solutions can be applied. We are very, very grateful for your time, for your presence here. And I really hope that you enjoyed this time today. I really hope you learned a lot. If you have some questions, you can send us to some emails to know more. You say, oh, Gabriel, I produce a lot of, I don't know, juice. I want to learn more about that. I produce wine. I want to know more about the specific details about wine. I want to understand better. You can contact us. Our team will be ready to answer you and to, as soon as possible, and to give you the solution, the orientation you need. So you can find here our phone, our email. You can find our YouTube, where you can see some videos about not only food and beverage, but also many other industries about heat exchangers, all the content we produce. And we also can find our LinkedIn account. I guess it's going to be shared in the comment very soon. So yeah, I'm very grateful for this time. The year is coming to the end. I want to thank you a lot for trusting us. Now, for those who celebrate Christmas, I wish you a Merry Christmas. For those who don't celebrate, actually, for all of you, I wish you a very prosperous 2025. I really hope we can keep attending our webinars. I really hope Hoffman can still be delivering value to you, be adding value to you, so that we can keep learning together. We can keep in contact, cherishing our relationship. And once again, thank you so much. Hope to see you very soon in our next webinar next year. Count on us. Well, if you have a question, you don't need to wait for the next year. You can send to us already. Thank you so much. Thank you so much for being with Hoffman. We are here to support you, to deliver the best solutions for you or for your customer who also may be using the heat exchangers in the food and beverage industry. We are here, hearing, focusing, and making in order to deliver the best for you. Thank you so much. We will not be here without you attending us and being present and sharing this moment with us. Me, myself, as Gabriel, I'm very grateful. Thank you again, and hope to see you soon next time. See you next year. Merry Christmas. Happy 2025.